Hello, this is Jeff Giraud, and today we're continuing our series of videos on simple blockchain to achieve certification of regulatory requirements. So this is our sixth episode. I'm not going to present again all the five previous episodes. You can go back to the fifth episode if you want a summary. But today I'm presenting what I think is the optimum blockchain / relational database for version control and configuration management, and to ensure that all of the traceability are in place. This is like, in the strict sense of the blockchain definition, the most basic blockchain that you can have. It's not complete. It doesn't have all of the security and the fraud prevention that like a Bitcoin or an Ethereum would have, but for a simple type of proof of stake requirement, it's sufficient enough, in my opinion. You get the most value for the least technical effort required. Okay, so some keywords: BC, blockchain, RDMS, relational database management system. And what we're doing here is we're using a Google spreadsheet with its version history feature as a blockchain and version control system. I'm going to make this file publicly available later. If you want to see it, it's going to be in the description. So let's start. Okay, so this is a relational database, which means that you have a master table and a child table. So like, this is the master table, and you're going to see that all of these columns are also column in the child / detailed tables. So like, you see ID requirement here, and you see it here as well. So like, all of these information and this table are data validated in the system, so that you're limited to these values. So that's what makes a relational database. Like, all the tables are related. So for example, ID, means of compliance. If you go to the means of compliance, you have the table here. So you have the clause and the means of compliance. And if you go back here, you're limited to this. So those indexes here make the table related. So it's a very basic relational database in the same sense as you would have an SQLite. It is compatible. You can use SQL command and import SQL databases like your typical Oracle, MySQL, SAP, etc. in there. So what we have here, each record is not only a relational database, but it's also a blockchain, in the sense that the value in the record is hashed, right? So you see this is your hash. So you see the concatenation from B2 to J2, and then you also concatenate this line, the entire record here, but you also include the previous one. So this is your block, line 2. This is your block from here to here, and then you concatenate, you hash that block here, and then when you have your next block, you also hash it, but you concatenate it with the previous hash. So that's your chain right there. This connection between this block, which is represented here, and the next block represented here, and its hash function, that makes your blockchain. You see, you start here, B2 to J2, and then you go here, B3 to J3, including A2. So that makes a blockchain. And yeah, so the function that we're using here is like a very basic MD5, but if you want something more secure, you can use a SHA-1, SHA-3, or a SHA-256. So, which is like, SHA-256 is like very typically used in typical cryptocurrency. So that's basically it. You know, here you have like a very simple, very basic, but at the same time very powerful blockchain, and the very basic word definition as per Wikipedia. Maybe we can look it up here There may be a definition. Let's just do this here. Wikipedia. So let's see the definition. A growing list of records. Yes, we have that. Our list of records, blocks, and they're linked cryptographically. That's our hash function. And yes, you have your hash here, including the previous timestamp. Yes, we have the timestamp here. If you look, you have your index, and your timestamp, and the previous block. So that's it. That's like a very basic blockchain. So you can use this for all kinds of certification. We've already used it for drone certification, maintenance, asset management, qualification to ISO 9001, AS9100, counterfeit prevention. There's really no limit to what you can do. So again, the manual, oh yes, one last thing. The Google spreadsheet and the Excel don't come with a natively cryptographic function, so you have to program it yourself. And the way you do that is you go in your menu, and there's a function that you can add in the script, and you just add the function. And this is the function for MD5. You just cut and paste it. And the function for the SHA-1 is this here. That's your SHA-1. So you just go in the menu, and you go to your what is it? I don't remember now. It's you go to extension app script, and you create a new script. It's going to look like this. You remove what they're offering you, and you just cut and paste this, save it, and then you're going to be able to call these functions MD5 and SHA-1. So if you go here, this MD5 function, that's not, if you don't program it in the script, it's not going to appear, so you have to program it yourself. And the same thing for SHA-1 here. SHA-1, you see, you have to create those functions in the app script, and then you'll be able to blockchain your records, your every line in your database. And that's it. Thank you very much for your attention. Please don't hesitate to contact us in the comment section. If you have any question or comment, I'll be happy to answer them. Thank you. Have a nice day. This is JF signing off. Goodbye.